thanks for the makeup biography. You know, he promised me yesterday that he'll come up with something unless I send him the stuff in time. So it's definitely more interesting than what I actually do. But so my talk is going to be slightly different because I looked at all the talks yesterday, and I think majority of people are coming from the perspective of developers and how do we do development testing better. I'm a QA engineer, and I actually want to do QA. When I left Purdue, I decided, well, first, being overworked and underpaid is just not all it's cracked up to be. And the second thing is I wanted to know why the software suck. You know, I mean, I'm an engineer, and the bridges don't fall out on a daily basis, and people get really annoyed if their cars blow up. So why is it okay for Microsoft Word to crash on me 15 times a day, and yet when Pentium bug had a problem, when the Pentium chip had a problem, everybody was up in arms and they wanted their chip replaced. So what's the difference between a piece of hardware and software, and why does hardware work and we expect it to work, and why does software suck? And I think I actually have an answer for that, but the topic of today's presentation is slightly different, and it's really a QA presentation. So I don't have a new framework, I don't have new infrastructure, but what I really want to focus on is how do we use existing pieces in getting something as important as performance testing done. And one of the things that I should also mention ahead of time is I'm a very strong Unix bigot. I've loved Unix for a long time, and part of the reason why I joined Google was that after a couple of years of being recruited by some of my friends, I realized that Peter Norvig is there, and anybody who hates PowerPoint as much as I do cannot be a bad person, and the place where he works has to be a good place. So this is my first PowerPoint presentation ever. I needed to apologize for it, and it's probably the last one I'll ever do, but more on to performance testing. Right, so Google has an interesting problem, right? Obviously, we launch things all the time. Quite often I will get an email saying, actually the last one was like at 4 p.m. saying, okay, we're launching today, could we do some performance testing? So, why bother? I'm sure it's good, you know, just sit it out. And I'm sure you guys have seen some of the results of efforts like that. But in general, we are getting to the point that solving the problems by adding more machines is just contrary to our mission statement, which is let's try to conserve resources. I mean, sure, you can always throw more machines at it, but eventually you run out of space, you're using too much electricity, and it's just the wrong thing to do. So what I'm going to talk about today is first a little bit about terminology, because performance testing, at least since I left AT&T Labs, I've noticed that we don't really even have terminology standardized. So I'm going to say what I mean when I'm talking about performance testing or reliability or availability, scalability, or anything else, because typically people come to me and say, like, you know, I need to do stress testing. And I go like, okay, so what do you want, right? And performance testing. Okay, so give me more. And there is never anything coming back, anything useful that will let me start. So then I'm going to talk about why bother? You know, I mean, why are you even interested in testing performance? Mention a little bit about tools, and I do want to say I have very strong opinions on what should be done with tools, so take it with a grain of salt, right? Everything is coming from my perspective. I'm going to give you some examples of what we have done at Google. Hopefully all the proprietary information taken out. If not, I won't be working here a week from now. By request, I'm going to say, how do you start performance testing? Because I actually don't think this is very hard. I mean, it's really not that difficult at all. I think it's a lot more is made out of performance testing. It's actually a fairly simple process. And then I'll open it up for questions and hopefully answers. So let me talk about, first of all, what do I consider a performance test? So anytime you run a test and you're actually measuring how quickly a system responds to workload, that to me is a performance test, right? So in a sense, you're answering the question, given the load X, how fast will the system return the result, right? But the important thing is I'm really interested in that time. That's what I'm measuring. Like in the case of the stress test, what I'm really more interested in is when will the system fail and how will it fail? I don't necessarily care about how fast the response times are, but what I really want to know is under what load will the system fail. And hopefully it's going to do so gracefully. I mean, I really don't want it to blow up into people's faces. Load test, for me, means I'm putting certain load on the system, and what I want to find out over a prolonged period of time, how will the system behave. Typically, the load that we're talking about is reasonably high load, right? So if I'm putting one query a second on a Google system, it's a load test and I can hold it for months, but it's not going to give me any useful results. But in general, for my load tests, I'm going to mention that later on, we try to use about 80% of the maximum load that the system can handle and see what happens if you're running the system under that load for a long period of time. One of the things that we typically focus on at Google, and we're trying to benchmark all of our properties, is basically create benchmarks for any particular feature, any service that we have, and then constantly run and continuously run benchmarks to understand how the code changes and evolves over time. And so a benchmark test, most important to us, is, as the slide says, it's simplified, it's measurable, and it's repeatable, right? Those are the three things that are very important to me. And in general, so I like benchmarks when they're used right. They tend to be misused in the world because typically the vendors will use benchmarks to game the system so that they will sell you their product and say, but look, on PPCC we do so much better than X company. And if you use them in that way, then you're completely misusing what their purpose is. But basically what benchmarks to us mean is let's try to figure out what the customers or what the users are doing out in the real world. And then let's extract some subsystem or subset of those operations that we can reasonably easily recreate and that it reasonably well represents the behavior of the system. And then every single time when we make a code change, let's run that benchmark and find out, did we mess up the system to the point that it's unusable, or did something really change tremendously? So we tend to do a lot of benchmark testing. Now, tied into this, and typically when people are talking about performance testing, what they're really interested in is scalability testing and a little bit of performance profiling. And scalability means if I increase a particular resource, so for example, on a typical system where I may have clients and then some front ends and a load balancer in front of them and then back ends and so on, what if I have 5 front ends as opposed to 10 or as opposed to 15? If I double the number of front ends, how will my throughput change? Or if I double the memory in the machines, how will the throughput change? Or what if I change the processor? So some particular variable is being changed, increased or decreased, and I want to understand how does it affect the performance of the system or the throughput of the system and what can I do with it. Performance profiling is something that the testing group at Google doesn't do much of because it's usually done by development. And what we have found out is that typically we can remove 80% of the problems with the testing effort. Profiling tends to be tedious, expensive, fairly difficult. You're running on a specially instrumented code, and you really want to do it only when there is no other solution, right? So in a sense, let me first go for the low-hanging fruit and run my tests and run some benchmarks and find out why is your system failing, how, and where. And then, and only then, if we know that the problem is right here, and I can't figure out any better way to understand exactly why, let's run some performance profiling tools and figure out, which particular routines are being called, how often are you calling them, what is your heap size, how much time are you spending in each routine, and then find and figure out which routine should be optimized and made faster. Tied again into performance testing, reliability testing. So typically, when I was at AT&T, we would run for about a month at a time after everything was done, just to find out that the system can actually stand up and contain and then basically work fine with the load for a prolonged period of time. So basically, reliability testing, and I honestly believe that you should do it on pretty much any product that you have, run for at least 72 hours, and find out how is your system handling the load. You'll find out strange things happen. People are running background processes at 2 a.m. because nobody else obviously uses the system at 2 a.m. And you'll have a developer saying like, okay, so I'll just transfer these logs from here to there. And so if you're not hitting that time period, you will never realize that there is a huge performance impact at that particular point in time. Availability testing tied to reliability. And I know Michelle and I have had a big discussion because he doesn't like the term reliability in this sense, but it's when people talk about 4 nines, 5 nines, and so on, that's what they're talking about. Availability testing is something slightly different, and it basically says when a system fails, how quickly will it come back up? So if you have to take a hit and if something goes down, you really want to be back up as quickly as possible and taking money from people. So availability testing tells you, okay, so finally something has failed, but can it be back up online very, very quickly? And in case of a company like Google, where we have systems failing really all the time. Our systems are designed so that we know that at any point in time there's probably at least 1,000 machines failing right now. Our systems are designed in such a way that nobody should ever be able to see that, because we basically buy crappy hardware and say, we know hardware sucks, so let's handle this in software, and it works really well. Now, the most important question to me is, when people come and say, I want to test performance, and I'm launching today, why do you want to test performance? And one of the common answers is because there's a checkbox over here and they say I have to have performance testing. And in that case, they just go like, okay, so here's a red marker and just check it off. And be done, no problem. So in general, you should want to test performance for one of these reasons, right? So you want to find out, can my application support what I think the customers will want, right? So in case of Google, you will see that on Google search, we are absolutely paranoid about how fast we get those results back to you. And if you look in the upper right-hand corner, one of the rules is it has to be less than a second, but we typically return the results in like 0.1 seconds or something like that. I mean, this thing has to be fast because it's one of the things that we say. It's our kind of trademark and distinguishes us from the rest of the world, and we will return the results faster to you than anybody else. One of the more important reasons is if you have some sort of legal requirements, or if your department has promised certain things. So in case of Google, we actually manufacture an appliance that we sell to the companies. It's the only product, I think, that we sell. We sell to the companies and basically searches your internet. And when we manufacture the appliance, there are certain guarantees, and we say, okay, so you can support this many queries per second if you have this many documents searched. And when you say that, you actually have to have the data to back it up, because if you don't, you can run into trouble. I mean, you can have customers going, and well, can you prove it? And performance testing will help you with something like that. When you are, if you have any kind of hardware situation, as new hardware comes out, you have to do testing with different manufacturers and figuring out what sorts of impacts will the new hardware have on your future platforms and so on. So again, you can do performance testing for that reason. And ultimately, a peace of mind, right? If I finish my performance tests on any particular product that we have, at least, I look at it and say, okay, well, it didn't crash in 72 hours. I mean, it worked for at least a period of time, and I feel a little bit more comfortable sending it out. One of the things that, and I forgot to put it over here, why you shouldn't test performance, and my personal pet peeve is when people call me to test performance, it basically means please test the functional subsystem, the threading subsystem of my system. To me, that's functional testing. And you really should have somebody else spend 15 minutes executing 5 or 6 things in parallel to make sure that you don't have deadlocks and priority inversion problems and stuff like that, because my time is, by the time I sit down and write the scripts and everything, do everything, and launch the load and find out that everything is crashing because somebody has taken a lock and is not releasing it until something else happens, I get fairly annoyed when that happens. So before you ask your performance team to do something, make sure that all of the functional testing has been gone through at least once. Now, the reason why I think people consider performance testing really hard is that quite often when you're starting, you don't really know how to set things up and how to organize things, and you end up discovering all these things that really should be published somewhere, but they're not. But if you set everything up correctly to begin with, it's really not that difficult. So what do you need? You have a system under test, right? This is the machines that somebody's going to deploy something on, and this is the thing that you have to test, right? Other than that, what do I need? I need machines that will generate the load, right? I need the machines that will be monitoring, and those could be the same as so 2 and 3 can be the same machines, but they don't have to be. I need some sort of a data repository, so when I'm running these performance tests, those results should be going somewhere, hopefully a database. And then I have to have some way of displaying the results. And my one and only attempt at creating a graph. So basically, this is what the performance testing system looks like. And in all honesty, if you are testing more than one application, the only thing you should have to change is the red thing over here. Everything else should exist. Okay? Everything, the system doesn't change. So once you have all of the other parts, the stuff on the left changes, so somebody's installing different software over here. But I should have my load generating machines, and I should have a piece of software running on them, and the only thing I need to do is create a script for it. The monitoring scripts should more or less be the same. Hopefully, your company is not inventing the new monitoring systems for every new application that you have. The results parsing and aggregation, as long as you're not changing your load generating software, the results parsing and aggregation scripts remain exactly the same, but you have that. At Google, we have a performance database in which we store all of the summary results, and then we have a presentation layer on top of that database, and you'll see some of the results from it that actually presents the data in some sort of a meaningful way. And then we have the raw storage data, because a typical performance run will generate tremendous amount of data, and you don't really need to keep all of it, and I'll explain why, and what do we keep and what we don't keep. Now, one of the frustrations that I have, at least currently at Google, and I'm sure that at least some of you have experienced with performance testing, is that typically when people do performance testing, it starts by saying, hey, I'll just write my own little script, right? And I love developers and I hate developers at the same time. The first step, for some reason, is always, I'll just write my own little script. And I don't understand why. You don't sit down and say, well, I'll write my own little operating system, which I'll install on this machine, and then I'll have my own little programming languages, then I'll write my own script. So why do you write your own script or load generating things when stuff exists? Okay, why do we build these systems from subatomic particles when we have bricks? Come on. And so I love all of your tools and everything else, but I wish we would do more of reuse. It just seems like somewhere when you leave college, reuse just goes out the window, and everybody wants to develop their own little system, which is so much better than every other system out there. So I'm going to talk a little bit about what goes over here. In our case, as you can imagine, I personally believe that everything that goes here and everything that goes in monitoring is what you will have in real life, right? Because if you use any other kind of monitoring, you have to account for the differences in load that either a regular monitoring system or your special monitoring system is putting on the system under test. So we tend to use whatever, in our case, Google monitoring of our machines is over here, and my scripts actually get the information from the special web pages. We have the parsing scripts that will store the summary results into the performance database. The raw data stays in the storage. We'll look at it the next day. And if everything looks okay, it's going to stay with us for about a couple of weeks, and it's going to get tossed. The summary data stays with us forever. So back to the thing, and a little bit of a discussion, which I think is probably the most interesting one, which is this box over here. What is happening over here is load testing tools. And so before you decide, if there is nothing else to take out of this talk, right, here's one thing. Before you decide to develop your own yet another load testing tool, please take a look and see what is out there, right? And you have several options. In-house tools. Before you develop your own in-house tool, please use one of the 55 that we have at Google, right? I don't like them for several reasons, right? You have the advantages that typically is developed by a developer who is working on the product, and it's just really quickly to hack it up. And I'm going to be on a different project next month, and for that month, I'm going to still support it. And then after that, I'm stuck with supporting this tool that, a year down the road, it doesn't do 5 of the things that I want. And it's just incredibly expensive to support. And it's a pain. I mean, it's just, any bug I have to fix, I have to deal with it. It's just really a terrible choice, in my opinion. Disadvantage is huge. I can't share it with customers. I have, as I said, I have 55 different Google in-house load testing versions of tools that will do, load this or load that. I can't give any one of them to any one of you because it's Google proprietary code, right? So if I'm actually trying to publish a piece of data, and if I'm using this tool, a perfectly reasonable question is from somebody else saying, like, okay, so let me get this straight. You're testing Google product with Google in-house tool. I can't have access to code for either one of those. Well, yeah, of course I'm going to trust you because you just look so trustworthy to me, right? So anybody can question the validity of the results that they obtain through this, and I know I would. I mean, that would be like, if Yahoo were to come up with something like this, that would be the first thing, like, you guys got to be kidding me, right? What do you think I am, a monkey? I mean, just, figure it out. Tool maintenance, it always looks alike. I can just hang it up as I'm going along. This is probably the most expensive option that you can have. I don't care how expensive the vendor tools are. This is the most expensive way to go because you will end up having a full-time engineer supporting this tool for the rest of its life. And engineers are kind of expensive in Silicon Valley. So vendor tools, right? So these are the companies like Mercury, Segway, Webload. You know, they make their money by selling you this product. And I don't have a problem with that. I think their products, some of them do pretty much a decent job. The problem is their pricing structure is just ridiculous. You know, you have, look, if anybody has $250,000 extra, see me after the talk. I'll help you out. You know, but why in the world would you spend this much money on a tool that doesn't do anything that your open source tool doesn't do? And I'm going to talk about those at last. So go and check them out. Another thing is these guys will get you into a room and spend 3 hours going through like the slickest PowerPoint presentations that you have ever seen. And by the time you're finished, you will feel that you've just lost at least 6 IQ points. I mean, every minute, right? So I honestly consider them guilty of like wasting at least 5 hours of my life at different points in time. The tools are professionally developed and maintained, right? So you get the bug fixes reasonably easily. Results can, so one of the nice things about these tools is in some companies, and I don't know whether yours belong into one of those, they create the reports, totally meaningless reports, but like really pretty. And majority of managers, that's all they want. I mean, that's what performance testing means. Give me a graph that looks really, really pretty that I can show to somebody else. Nobody will know what is going on, but we can check off the box. These tools are really geared well for doing that. And you can't do that with JMeter, but LoadRunner, Webload, Segway, Silk Performer, fantastic. In my opinion, they're extremely expensive, and they don't give you the value for the money. They all have proprietary scripting languages, and some of them will tell you, like, oh, no, we are using C. That will be Mercury. Well, yeah, it's C minus the pointers and minus this and minus that. Well, okay, great. That's some C that I can use, right? Silk uses BDL, benchmark definition language, completely, brand new language. And so if I get this tool in, that just makes me require people to learn yet another scripting language. And along with load testing tools, I think the world doesn't have enough scripting languages, and we really need a couple of more. You don't have access to source code. If your tool, if you need this one thing, right, and you need it 6 months from now, you don't have the source code, and this can work really well, or it cannot work at all, depends on how much money you have. When I was at AT&T, Segway would fly developers from their Austria office to just get the work done for us. But we had however many $1 billion to spend and waste, and they would do that, right? But in general, if you're not giving them outrageous amounts of money a year, you're never going to get your feature in, right? So, and you can't help yourself because these things, you don't have the code to it. Open source tools. To me, this is the answer, this solution, and they really, 5 years ago, they just weren't there, but today they are. My personal preference, JMeter, again, keep in mind I'm a Unix bigot, and that's why JMeter is strictly my preference. But if you prefer something else, take a look at OpenSTA, take a look at Grinder. All these tools are listed on Apache website, and they're really neat little tools that can be used for different things. Depending on what you're testing, you may find that a different tool will work for you. So typically for anything front end, so anything GUI, we tend to use JMeter. For API testing, we have applied Grinder successfully. We don't use OpenSTA very often because it is Windows only. And if I want to create tremendous amount of load, I want to distribute things to my Google data center machines, which are all Linux machines. So to me, obviously, JMeter and Grinder tend to be the two solutions that I like the best. The price, and I should say acquisition price, is really good. You do have to occasionally develop new features in it. I mean, it's when people say free software, this is one of the things that I actually agree with Scott McNeely on. It's free in the sense that the puppy is free, right? So, you will acquire it for free, you can go to the pound, but after that there is certain expense. And it's there, but it's still cheaper, a lot cheaper than an in-house tool. What is nice, or what we have at least found with JMeter, is that whenever we develop a mod, something that we like and we really need, and we send it back to these guys, they're thrilled to include it in the next version. They just are great to work with. They really want people to use their tool. They want, this is development that they actually don't have to do themselves. You have to go to their standards, and that's fine. But in general, you can do your stuff, send it back to the community, A, you're giving back, B, it's shared with other people, and C, I don't have to maintain it after that. To me, that's the big part. Trivial for me to share my results with anybody else. You want to verify how many QPS, Google Search Appliance can handle this? Well, here is the script, download JMeter, it doesn't cost you anything. And I'm not asking you to spend $250,000 to get Loader Runner to be able to do this. You can have it up and running in a day, right? You do the scripting in standard programming languages, more or less, right? So to me, that is a big advantage. I don't have to learn yet another language, and I don't have to bother with training every other new person that comes in the project on, you don't use semicolon here, you actually use colon colon or something else that for whatever reason this developer has felt this is the feature of my language. Disadvantages, support for protocols. I think this is one place where vendor tools are actually stronger. They support far more protocols than open source tools, but as long as you're staying in the web space and you're looking at HTTP, HTTPS, I'm at POP3, the open source tools are pretty good. Being at Google, that is one of the things that works in my advantage. It's a little bit steeper learning curve, right? You don't have slick presentation materials. You don't have somebody come to you and offer you a 2-day class on the tool. Why would you ever need a 2-day class on a performance testing and load generating tool? It's a different story. But there are some things, there are some little tips and tricks. And so if you pick a tool like this, the best advice I can give you is find somebody who has done something useful with it, or find a couple of scripts that work. Because there is always these 2 or 3 things, like in case of JMeter, I'll give you an example. If you have a data file, the data file and the script have to be in the same directory. I think they will fix it for the next version, but it doesn't say anywhere, right? You can have a link to the data file from the same directory, but they have to be in the same directory. And so if you put the absolute path names, the stuff just isn't working, and you find yourself banging your head into the wall going like, why is this not working? It should. I mean, look, it should. And then you find out, oh, it's a bug. Here's why it's not working, and here's how I fix it. But these kinds of things can cost you a lot, and you can actually find yourself saying, well, these tools just suck, and they don't do anything, and I'm not going to use them. It's worth spending an hour with somebody who knows how to use them and show you these 5 or 6 different things, and basically what exactly? Oh, no, don't want to take them. But that is pretty much, in my opinion, the only disadvantage of these tools. Everything else, plus. Results of a performance test. So you're running your performance test. You have your stuff going on. One thing you will find out about performance testing is you're really good at generating data. I mean, you want terabytes, I'll fill terabytes, no problem at all. The problem is, what does all of this mean? And quite often, you need to look at this data and you need to extract information. And I think the biggest problem I have with performance testing is that a lot of time people just have the data and don't know what exactly to create out of it. And I'll show you some of the graphs and some of the ways of looking at the data. So for every performance test, we create a tremendous amount of raw data. So during the performance test, every transaction is being tracked, and the performance testing tool like JMeter will track everything and say, okay, I've sent this request at this point in time, at this point in time, and it's come back. This is maintained. So obviously, if my tests are running for a couple of hours or days, that is a lot of data. But then in addition to that, for every machine in the system, I have a track of CPU, memory utilization, disk I/O, possibly some additional variables. So as you can imagine, this is a tremendous amount of raw data that actually is generated by a single run. Multiply by the number of systems that we have, multiply that by the number of tests that you run, and you realize even at Google, pretty soon you start running out of disk space, right? So I'll show you a couple of things now and a couple of examples of a typical performance test, right? So this is a very short performance test. You're called on a project. People are speaking a completely different language. This, I think, was our ads folks. And they have their own words for everything, and you have no idea what they're talking about. And you'll see here we've called users as normal users and premium users, and they actually have a different terminology. But I don't know their system at all. And we need to get the performance tests quickly out because we know that we're having problems. So what we do first is say, okay, so you have 2 different kinds of users. Where are you guys having problems, right? And so, well, we're having problems with this feature over here. People have been pissed and been calling us and saying, you suck, right? Okay, so I don't know at all. I have no idea how the system is performing. The first thing I'm going to do is I'm going to pick what I consider, or what they've told me are the most important variables, right? So we have these two different kinds of users. We're looking at this one feature, and I'm going to find out, okay, I'm going to keep a certain set of users, in this case premium, fixed, and I'm going to vary the number of normal users, run short tests. This is what, 300 seconds, so about 5 minutes tests, just to see what is the system doing, how is it responding. And as I said, in this particular case, since I/O was not interesting at all, it's not listed on here, what I'm plotting is the memory is the red line, the CPU is the green line, and then my throughput is the blue line. And I should also say the scale on the left is the throughput scale, and the percentage scale on the right is the scale for the CPU and for the memory. And so I'm going to repeat this with a whole bunch of variations for the number of normal users, and this is on a small subsystem that we've set up. And what I'm really looking for is the blue curve, not the blue curve, but let me see, the red curve, I think. Yeah, the normal user throughput. This is the curve that I'm looking for, right? This is I want to find out, as I'm increasing the number of normal users, which is the load on the system, what is happening with my, in this case, reports per second, what is happening with my throughput. And what I also want to find out is which particular resource of the system is going to be exhausted, right, and at what point in time. And notice that already at 8 users, my CPU is going up to about 100%, right? So on some level, what I'm doing here is a stress test. I keep increasing the load, and for every one of these runs, I'm trying to figure out, okay, how much of my resources is being consumed, what is my throughput, and at what point in time will my system be exhausting at least one resource to about 100%. In general, when it comes to Unix machines, and if you're running Unix-based systems, I would say don't go above 80%. Unix is a wonderful operating system that will do anything you ask of it as long as something is not above 80% constantly, right? So the moment you start going above 80%, you can't trust what's going to happen. And so in general, we look at this and say, okay, let's go back to about 80% line. And that can be memory, that can be I/O, or that can be CPU. I don't care which one, but always stay below 80% of the usage. And so you run a stress test like this, and then you run a different stress test where you vary the number of premium users or the other parameters. And basically what you're looking for is your really optimal point where the system is going to get loaded the most, right? Once we've done all of this and figured out how the system behaves, we sit down and talk with the guys that actually do live support and find out what would make a decent benchmark, right? So I have my developers, they have new features, bugs, everything else to track, and what I really want to give them is something that will allow them to find out as quickly as possible, preferably within 24 hours, I've just introduced a code change that will really hit performance and the users out there badly. And therefore I should go back and fix that today rather than 2 weeks from now when I have no idea what I was working on and I have no idea why I did it. And so what we really do and how we do our benchmark tests is, you'll see one of the cases over here. These are the guys that we were concerned about. These are our premium reports. And at some point in time, one of the candidates, so the purple graph over here is one of the candidates, and then suddenly we introduce a code change over here, and the performance has gone up by 100%. We basically doubled the amount of time that it takes to get the result back. Clearly, the developer didn't intend to do that, but was fixing a bug, doing something else. And if I can get this feedback, and to me, this is the biggest value of performance testing on a day-to-day basis, right? Because I can give the feedback immediately and say, hey guys, something has gone wrong. From yesterday to today, here's what I'm getting. They can look it up, they can just go to our front and actually have graphs immediately generated for them. And every day in the morning they come in and they can look and see how is the recent code change or the recent build performing compared to the other builds. Right? And then you will see also that the follow-up builds have fixed the problem and immediately targeted the particular, both the bug and the performance issue, so that we don't really have a problem when we go out live. But to me, this is the biggest value of performance testing that we're doing at Google, and that is instant feedback to developers. I can run on a nightly basis, they can trigger off the tests on their own, everything is automated, all of the results go directly to the database, everything is tracked. We actually have, I should say, 2 different databases, so we can actually store the binaries that we're running on the machines at the same time. as the one that I tend to use stores just the labels of the software that we're running, but we do have the ability to store the actual binaries. So if somebody is messing around and trying to figure out how will the different switches in BIOS impact things, we can store all of those things and analyze it. People can look at the graphs and find out how the performance is working. An example of scalability testing. So you're looking at a new configuration, right? You have a hardware platform, you are running out of parts, and you're basically looking for the next generation hardware platform. What is really interesting is working with finance people, because for them, like $20 is a lot of money, right? And so being a geek, I sort of, when I'm buying and building my own new machine, I always look at it and say, how much memory can I shove into it, and what's the best graphics card? And then you're working with these guys, and you're going like, well, it's only $20 between 1 gig RAMs and 512, and they go like, wow, $20 times a million machines. And so, oh, okay, whatever. I know I would never think about it, but they do. And so what we do is we tested 4 different memory configurations, and these were all tested on 5 to 10K HTML files. And just to also point out, this particular machine is really only sold in this range. So whenever we are testing, we go and test far out of the range that we know that we will sell the machine for. Right? So in this case, the index size was varying from 100,000 machines, it's a small machine, to about 1 million documents, sorry, 100,000 docs to 1 million docs. Testing on 5 to 10K HTMLs is very important to us, because the average size of an HTML document out on the web is about 7K. We also test on the larger files, because obviously if you're crawling Word documents or PDF files or anything else, we actually convert those, we store them, and they're much bigger. But if a company is interested that they have only HTML docs, chances are their sizes will be about in this range. And so one of the things that happened, originally we were just telling people, so we will guarantee you 5 QPS, and you can see it on the website, and we were always saying, like, okay, we'll guarantee 5 QPS. Well, if you take a look for the machine that is selling within 100,000 documents to 200,000 documents, we are actually doing 50 QPS, right? But you cannot look at these systems as this is the throughput. I mean, it depends on what the condition is. And so one of the things that we ended up doing with our sales force is saying, like, you have to look at what the customer is going to do, because you're getting pounded by the competition saying, well, we can do 20 QPS under these conditions, and we are saying, well, we can do 5, when in reality I can do 50, depending on what my configuration is, how much memory you put. But even in the lowest, if you look at the configuration, whatever 3, even in the lowest form, I can do 45 or 43 QPS. So before you pick whatever is the lowest number down here at the bottom of the scale, I realize that you're talking about graphs. You're really modeling the performance of the system. You're talking about charts. You're talking about graphs. And that is the thing that should be presented to the customer, rather than some lowest number and then get pounded by somebody else who actually is presenting data in a more accurate fashion. We'll also notice one thing. Every single time we run a performance test, or if I'm unfamiliar with the system, I don't trust it. I'm a QA person by choice, and one of the things that I realized is that A, the systems will fail exactly in the place where the people tell me nothing could ever go wrong. B, developers are totally delusional about their own software. And frequently they will just forget about things that they've done 2 weeks ago. I know if it's not in my inbox, it's not going to get done. So I run every test. Here you have only 3 results for every set, but we run every test 5 times. I want to see that I have some sort of a statistical consistency. And depending on the software, you would be surprised how the results can be all over the place. And you go back to people and say, you have some serious problems. Because clearly the data is going to be a little bit off, and you have to do some statistical analysis. But if you are finding that your results are 50% or 60% off, you have a problem. Your system has a problem. Something is wrong. You don't understand something about it. So this is an example of scalability testing. Now, I recently had an interesting conversation where a person said, like, oh, you don't really have to monitor memory because we know memory is not a problem. And you may know for a fact that memory is not a problem and you have enough memory and so on. The reason why I want to monitor memory is cases like this. Performance testing should not be used as a tool for finding memory leaks, but it can, right? And so this is one of the examples of many tests, and this is my per test data, right? So I look at this, and it's a relatively short run again, and I've had millions of graphs like this from the same machines where my memory red line was completely straight. And we come in the morning and my graphs are waiting for me, and I look at it and I go like, uh-oh, something is not very good, because this line has always been completely straight in the past, and now suddenly it isn't. What happened, right? And you file back email immediately to the guy saying like, so take a look at this chart. I think you have a memory leak, and you get back like, memory leak? Us, never, right? Oh, wait a second. Yeah, you may be right about this. And it's, the data doesn't lie. I mean, the machines didn't decide to hate you this day. But this is why you do monitoring, right? Performance testing, honestly, performance testing without monitoring, don't bother. Why waste your time, right? Go get a cup of coffee or something. You have to monitor the stuff. Do you have to keep this data forever? No, because majority of my runs, I'm going to come back in and say everything is okay. I'm just going to keep the summary stuff. I'm going to toss this data after 2 or 3 weeks because nobody really wants to look at it. But this one, the moment I have this one, people will jump on it and look at it and try to understand what is going on, because it's telling them, okay, I definitely have a problem. Once the problem is fixed, the data also goes, the summary data stays, right? The information stays. But all of the raw data that created this chart, why do I care about it a year from now? The problem has been removed, and that's pretty much the only thing that I'm really, really interested in. So I've heard that several people here are interested and have been told you need to do performance testing. And we're looking forward to the talk, because they're going like, okay, so I have to do this. I have no idea where to start. So I'll try to give you a hint. First of all, you've seen the setup, and I think I have another slide of it. You need to set up everything that will allow you to extract the information out of your data, and that will allow you to use the data, right? So the information. So the database has to be involved, and in our case, it's MySQL, right? Again, we are heavily open source, and MySQL works really, really well. Set up a schema that will allow you to keep the average throughput for a run, the names of the machines that you're monitoring, the average CPU memory, average disk I/O. Let me see. We definitely keep track of every single piece of software that is running on the machines and the versions that are on there. All of that is in the database. All of the data needs to be easily accessible. We have queries set up that pretty much anybody can go and check and find out what has been happening with this particular project on these particular machines. I will also definitely agree. Yesterday, a speaker has said, every once in a while you will find a machine that just is different and behaves differently. I can even tell you why that is. In my previous company, we at some point in time partnered with a large hardware manufacturer from Texas, won't name any names, but they were going to provide us with the machines. And at some point in time, Network Appliance provides these things called filers, and they store data, and it's kind of, people really get ticked off if you lose all of the data, or if you allow it to be seen all over the world. And so we started getting these boxes from the said manufacturer that were all supposed to be exactly the same. We found out there's about 4% error rate in the boxes, where you just got the wrong part in it. And we called them back up and said, so something's wrong, we're getting 4% error rate. And they said, oh, that just about sounds right. That's okay. So I would guess that, so if this particular manufacturer has that issue, I would guess that all of the others have error rates that are high enough. And so some of your boxes will be different. They're different because they have different parts, the ones you didn't order, but you have to realize that if you buy millions of machines, that will happen, and it's a good idea to test and know what's going to happen when you have to deal with that case. So first thing, set up a realistic environment, right? One of the most frustrating things is being told, okay, so here you have this Pentium 3. We would like to know how will this work on a supercomputer. What can I tell you? I can't really tell you much. But what I can say is, typically I can tell you what is the resource you're exhausting. And if you have never done any performance testing before, chances are you will be able to remove like 20% or so of the bugs that will cause 80% of your slowdown. Worked on every one of our projects. It's really 28-year-old works. Don't know why, but it does. So set up your system, understand what are the machines and what are they doing, and make it realistic. What I mean by that is, majority of Google developers are really great about testing, but we test with zero-size databases, right? Because you're a developer, right? You have your own little setup. You're not going to go out to the real world and create a serious database, and it works just fine on your machine. It's quick enough. And then I load a production database, and the stuff is not working at all. So if you're going to do any performance testing, make sure in particular databases are somewhat realistic. I mean, they don't have to be exactly the same as production, but they have to be the same order of magnitude. Otherwise, the results you're getting are just completely off. I mean, you can't really do anything with that, predict what's going to happen out in the real world. Once you have that, you can model and you can extrapolate, but make sure that, again, that you understand what are the risks and what are the problems that you can encounter. Second thing, execute a stress test. Find how your system is failing, find where it is failing, and then, as I said, depending on how critical your product is, 60 to 80%, it's, you pick it out of thin air, but on the Unix machines we find, don't go above 80%, and you'll be happy. Do find out how the system handles overload, because you really have no good defense mechanisms against people out there trying to or even in our cases, like when we launched Google Earth, predictions were like, oh, okay, we'll have about, I don't know, 1,000 people downloading it the first day. And for whatever reason, if you Google, and no matter what you do, somehow it ends up on blog, and within 15 minutes, we had millions of people downloading the stuff. You can't plan that. You can't protect yourself against stuff like that. It's just that the product is a lot more interesting than you ever thought. But in general, you should know how your system will behave if something like that happens. So run a really, really high stress test to find out what will happen, and hopefully you shouldn't blow up. Then you figure out what is your performance test point, and as I said, 80% is a good starting point, at least in my opinion. Execute performance tests. It has to be long enough, and long enough means you have to reach steady state. And depending on a different system, you may reach steady state very quickly, or it may take a couple of hours. But again, do some investigations of your system and run first a couple of short tests, and as you see the graphs leveling off, you're starting to reach the steady state. Start the test with a reasonable warm-up period. I think it's completely unfair to start 100,000 users all in the same second and say, oh, the server didn't handle this particularly well. Well, it's not designed to handle something like this. Make sure that those users are coming online slowly or over a period of time. Collect all the data, right? You may not want to keep it forever, but definitely collect all the data. The system performance is the lowest throughput for the duration of the test, right? So you will see that the throughput will go up and down. Usually happens because there are some background processes kicking off, I don't know, moving logs around. Log rotation tends to be a standard thing on Unix machines and so on. But you have to, when you're reporting your performance data, you have to report the lowest throughput, right? Because that is the only thing that you can guarantee. Anything higher than that, you cannot guarantee, because the people could be running at a time when your scripts are kicking off and taking some resources for something else. Repeat the test several times just to assure yourself that you do have statistical consistency, that nothing weird is going on. And debug is necessary. Other than that, questions?
Goranka Bjedov says, when you take your 5 samples on your performance test, if you get one that's very out compared to all the others, what do you normally do with that sort of value?
We try to go back and figure out why. So during all of this monitoring, I'm plotting some of the things over here and showing you, but we actually also look at what is running on the machine, which processes are running, and what is using resources. And that is how quite often you find out, oh my God, these people are actually kicking off this, what is supposed to be a low priority process that really does nothing, but it's running at like the highest level user, and then you can usually fix the problem with just nicing it down or something like that. But quite often people don't really realize everything that is running on a complex system. And in some cases you find that there are debug things left in there that people have forgotten to turn off. But we keep track of everything. So if I don't have that turned on, I will rerun all the tests with all of the tracking turned on to find out which process is causing the slowdown. What has happened? Because something must take place. So we do that.
Thank you.
Peter Freitling. Testing web pages with stuff like HTTP unit, that just tests maybe the HTML. How do you test the whole page, the images, the JavaScript, the style sheets in an automated way.
Okay, so JMeter has been absolutely great for that purpose. There are a couple of things you can do. You can actually ask it to retrieve the images or not as you see fit, and you can ask it to verify any of the things, right? So I can actually make sure that the image it is getting back matches the image I think it should be getting back. Same thing with JavaScript. We have had no problems. We had to do some extensions to it, but they are already in the product now. Same thing, HTTPS, we've added, and that's going to be in the next version of JMeter. We've added ability to record over HTTPS to it, and they've assured us that it's going to come out in the next version. JMeter is actually an interesting, not exactly most user-friendly programming environment because it's kind of graphical programming environment, but when it comes to record playback and then modify things, it allows you to do a fairly nice job, and then what is, to me, the most important and the nicest feature is that I can kick it off on a command line, and I can run it in non-GUI mode, and I love it for that. No problems with all. Verifications of any of the things, everything built in, get it for free.
Hi there, James Harvey from Encipher.
Okay.
Do you, you were talking about storing the...
Sorry.
You were talking about storing all the data from the test runs.
Mm-hmm.
Do you ever find that the act of collecting and storing the data affects the performance of the systems you're trying to test?
I should have mentioned that. We actually monitor also the machines that are doing the collections and so on. So it's the monitoring machines themselves that are actually collecting all of this data. It's not the machines under test, right? The machines under test, at least in our systems, are set up so that they send periodically information to monitors, and then we actually collect the data from the monitors. We do monitor also our both load generating machines and our monitoring machines to make sure that they are not overloaded and that my performance data is not skewed because the machines. So yeah, absolutely. Thank you for bringing it up. We do monitor that.
Kalle Raita from Hybrid Graphics. Have you had any attempts to automate the analysis of the results or anomaly detection?
That is the last step that we have left. So one of the things that we found out is it used to be fairly expensive to set all these things up. And let me go back to we have just recently we've just recently set up all of these pieces because this layer is still being worked on and all of the graphs are now there, but we're adding more stuff to it. What we would really like to be able to do is automate the stuff, the raw data, and basically that I really get the graphs printed on my screen in the morning only if something is wrong. Now I'm paranoid, so even when that is done, those graphs will be on every day for every project that I run because, you know, I know too many developers, and so I know how good my code is, and you know, there is a reason why I don't develop, right? Because I'm even worse, right? But I don't know, when it's something, depends. I'll say we will definitely be working on it. Would I necessarily trust it on something like ads, which pays my salary? Never. On something that doesn't pay my salary, sure, what the heck, you know, I mean, why not? But really, it's performance testing is really about risk analysis. I mean, QA is about risk analysis, right? And so if I believe it's high risk, I want to take a look at it. If I believe the risk is relatively low and I'm reasonably certain it's doing okay, I'm perfectly okay to let it go without, you know, really having a person deal with it. But we are working on it. That is, you know, one of the motivations is we all lazy, right? So if machine can do it, why should I have to? So.
Hi.
Hi. Yeah.
Hi, Shashi from Multimac. This is a question about reliability testing and availability testing.
Mm-hmm.
What I can see is that the measures for reliability and availability is substantially towards performance, stress, and load.
Mm-hmm.
Apart from this, do you have any other quantitative measure to see the reliability and availability testing is such? Because according to me, in the sense what I mean to say is that I would term reliability to be the mean time between failure, the mean time between the failure of a system. And I would have a quantitative measure with respect to the mean time to repair and the mean time to fix for that particular by way of SQL injection. So if you had to remove the factor of performance, stress, and load, do you have anything else to measure the reliability of a system?
Actually, we do, but it's done by the ops people, right? So in particular, and I don't even have the data for that, but in particular, all of our systems are really being monitored the whole time. And so I'm sure that our operations people would be able to tell you for any particular data center what is the mean time. Well, they would be able to tell you, I'm not sure whether they would tell you, but we do have the data for the machines. I don't really have access to it. Google is fairly paranoid about any sensitive. So for example, even when we do this, when I do searches, I can't get access to the real searches going out there. I don't know what they think I'll do with it, but honestly, they will not. The level of clearance you would have to get access to any real customer data is really astounding because we're very paranoid about protecting the user privacy or anything like that. And we're equally paranoid about protecting information about our machines and stuff that is used. So I know we have it. I don't have it personally.
Hi, Goranka.
Hey.
As you know, I'm your #1 fan.
Yeah. Thank you.
Anthony Marcano, by the way. Two points very quickly. A good source of open source tools, just for the benefit of the audience, is opensourcetesting.org.
Absolutely.
And the RSS feed,
And
that's also
somebody
aggregated on testingreflections.com.
Yeah, I was going to say, I'm sure there's a blog somewhere that lists all of this stuff.
But also, you mentioned particularly rapid feedback, which I think you quantified as being a day.
Yeah, so in general, I run all of my tests overnight because they tend to be relatively long, and you have 5 in a sequence and so on, and so pick them up before I go home, and then in the morning they're there.
So what suggestions would you have for developers who might want to get even more rapid feedback, say as part of their continuous integration builds, beyond just basic concurrency testing, perhaps with things like JUnit perf to help sort of augment that and get rapid feedback as part of their continuous integration build, so within minutes they know that they've actually introduced some fundamental performance issue and not have to wait an entire day for some of the basic feedback?
So I would say go with a 5-minute test run because it's going to give you some information. I would still insist on nightly runs that are a little bit longer. But if you're playing with the parts of the code that are fairly sensitive and can impact performance, and you want to get the feedback, just run a 5 or 10-minute test run. Make sure that all of the data. One of the frustrations that I personally have is that a lot of times people, when they run performance tests, they don't realize that the information is important, and I'd like to capture all of that information, even if it's for some build in between or so on. If you're running a test like that, store the data into the database. I mean, that's what it's there for, right? So definitely keep track of everything you're doing and augment it. I should have also added that in the database we have obviously fields that allow us to comment on any particular run or anything else so that people understand what is going on, especially if you are fiddling with parameters that are not exactly visible immediately. So, but yeah, you can get faster results. We are working on setting something up that would be even faster. 24 hours has been fairly reasonable for us, though. In general, people tend to remember the things that they have done yesterday, but a week ago is really hard. I mean, I know from me personally, I couldn't tell you what I was doing a week ago, so don't expect the others.
Do you include networking in your profiling?
Good question. I should have mentioned that. Thank you for bringing this up. When I'm doing performance testing the first thing I try to do is eliminate the network, right? Because I want to simplify my problem. I'm interested in the machines, and my hope is that the network is going to be provided to be able to handle everything I need. Now, once we have profiled all the machines and understood everything, we will do some tests typically between multiple data centers, right? And at that point in time, the network is included in it. But honestly, if you can, everything on the same subnet, everything going off of the same switch, and that's going to make you a much happier performance tester in the first pass. Debugging networking problems, fun. What else can I say? So yeah, but thanks for bringing it up.
Hi. One of the big problems about doing benchmarking and performance testing we found is that the marketing department drives it. So they want the biggest number, they want the highest number. So if I was to say to them, well, we're only giving it 80% capacity because that's sort of what users can expect, they'd say, well, what all the numbers are 100% capacity. Tell us the biggest number. So any advice on fighting off marketing departments?
Oh, lots. In general, avoid them, right? Because, but the funny thing is that, good thing about marketing people, you can always come up with some technical explanation that they won't understand. So, because the defects will blow up and it works. But in general, it's go back to the risk analysis and reliability, right? Do you want to run it at 100%? Sure. In that case, I can guarantee you it's going to be out for a day. you want it more than a day, you want to do what I'm telling you. One of the nice things, I don't even know that Google has marketing people. I've never met one, so it's really, but I've dealt with my fair share at Meta, and it's just sort of like, which planet do people come from? And why does everybody have the same haircut on this planet? But that's a completely different story. But yeah, but I also get a lot in trouble, so you may not want to follow my advice all the time. Yeah, it's honestly the Unix. I honestly don't know. I've heard that actually Microsoft is also doing some similar things, but they go down to 60%. So it's a standard thing. We know that when you come above a certain level, the machine will just not behave the way you expect it to behave. Things will just start going off. So.
Hi there, Ian Howard, JP Morgan. I'm interested in what you say about not extrapolating the results onto a supercomputer, because typically we buy supercomputers for production and sort of 386s for our QA. And consequently, when we do our performance tests, we get a certain set of results we're happy with, and it's actually, we find there's lots of failures, but we figure put it in production anyway, because it probably won't happen, and it generally doesn't. And I'm interested in how you square that circle, because clearly most people can't afford to replicate their entire production infrastructure for testing. I mean, maybe you can borrow it overnight, maybe you can take production data, but that's a very real problem that we have.
So I'll tell you a couple of things. At Google, I'm lucky, right? Because machines in our data centers, right, we have no supercomputers unless you look at how we have organized the machines that do act as one, but they're really individual boxes that are pretty much the same as the boxes I will have in the office. So I'm very lucky in that respect. At AT&T, so I joined AT&T after my 7-year stint at the university, and so that was a shock, because universities, at least in the U.S., are notoriously poor and cheap and just crappy equipment. And I came to AT&T and I wanted to do tests on, at the times, it was E5000 was a Sun stop line machine. And it cost a couple $1 million or something like that, and so it was and I get a call back from the department saying, like, so you've ordered an E5000, and we knew we were going to use it. And I'm going through like, oh man, this is now we're going back through like, there's no way you're going to get it, and so on. And they go like, well, so here's the thing, what if you order one, and what if something fails? Could we just order a couple and be done with it? Right? And so that's another solution. Work for a company that has an absurd amount of money and is not willing to go and is willing to go bankrupt at a drop of the hat. That was AT&T. In between, you have a real problem. I mean, you really want to get some time on that machine before it goes live in production. And if the system is not already live in production, it should be not that difficult to get it for a week or a weekend or something, so you get some data on how it's behaving, because you can't extrapolate the results from a 386. You don't even know. I mean, it's even a different operating system. It's everything is different. Extrapolation will kill you. Interpolation is great, but extrapolation will kill you, because things will just go wrong, or you'll run out of some resource that you never expected. I remember issues when our Solaris machines were not configured properly, and we had a limited number of file handles, and suddenly I would get these 2-minute delays when nothing was happening, because the system was waiting to start recycling the file handles and reuse them so quickly, and so now there was like a 2-minute timeout on them. And you'll run into stupid stuff like that you can't predict ahead of time. The only, validation is the only thing that you can do. You have to go in there and you have to run a test. At least I don't know anything else you can do.
Thanks very much, Goranka. Goranka Bjedov, everyone.